everybody, today I'll be talking about how to make a Resident Evil 4 inventory in Godot 4 3D inventory system in a 3D space. Let's get into it. Right now, let me show you what I got. Click on an object, left mouse button to select it, and then you can move it in the 3D space in this environment. And yeah, the bounds aren't exactly set up correctly right now, but I do have the correct code for that. I just have not implemented it fully yet, but I can click on another object, I can move it around in the space. Oh, there's some lag. And I can click on this cylinder here and I can rotate it. And I can move it into space. And yeah, the bounds aren't set up perfectly yet, but that's all going to be fixed later. But this is the basic implementation. But for right now, what I'm really going to show right now is how to set this up, how to get the infrastructure, the base set up before we even get into movement and rotations like that in the inventory. Because first you have to do two things. You have to have an object and you have to care about its position and its size. The position in this scenario in Godot, it is the center point. The center point is this. What I mean by that is the center point of that node 3D object is at the position, wherever the position is, that's the center point of the object. And for example, if we look at this heart right here, its position is at X is at 100. So, and that is the position of the center point of this mesh. And that is very important to know, because if we know this information, then we can do pretty much whatever we want in this 3D environment, and we can manipulate the objects as we please and bound them in the space and all that. So let's get into the code really quick here and get started here. So first off, we are caring about the size of the object like I just said. And this means okay. I'm sorry, this music, this song is so good. I'm just like soaking it in right now. So here we got the scale of the object. This is the node 3D object. Get it? And let me just back up for a second. Hold on. Pause. We're getting the size of a node 3D object in the 3D space. Right now, we want, let's say for example, we want to get the size of this heart. To do this, we have to do all of this code, and I don't know why it's not built into this engine. Like I could seriously write like so many libraries like for this. But anyways, I'm just saying, like, I just feel like it's weird that they don't have this like available, because to get the size of the object we have to get the actual scale of the node 3D parent object, and then finding the mesh child mesh instance 3D object and get the scale of that mesh instance, and then we have to multiply those two scales together times the size of the mesh, because you can scale the mesh in two different parts of the object. So this is just to get full coverage of the actual true size of any object in Godot. So that's pretty much all I have to say about that. But I mean, like, of course, find mesh isn't a built-in function, so please don't just copy and paste this. I mean, do please copy and paste this, but also find mesh, you're gonna have to implement this function because this is not built in. This is what find mesh is, and I know there's probably an easier implementation out there for this, but this is just a simply finding a mesh instance 3D object that's a child of the object in the inventory system. So if you're creating your Resident Evil 4 inventory system, please make sure that your mesh instance 3D object is a direct child of the node 3D object of the, you know, the whole object that's in the inventory, so that it can be actually selected. And it and in this case, I'm using ray casting from the mouse of the player. So let me show that really quick.
We want to be free. We want to be free to do what we want to do. We want to be free to ride. We want to be free to ride our machines without being hassled by the man. And we want to get loaded.
Here we go. Once the mouse button is clicked against camera ray, there's it's a ray cast from the direction of the camera of where the mouse is in the 3D space. And once it collides with an object, it has a collider. So then you can get the parent of the collider, which is the object in the inventory system. So what this means is that you're going to need to have collision shapes inside of your object. I'm sorry guys, but you're gonna have to have a static body 3D or an area 3D or a rigid body 3D object with a collision shaped 3D child of that, and that is necessary if you are trying to select these objects based off of ray casting and doing collisions with ray casting. You could select these items like in Resident Evil, where there's a grid and it's moving around selecting the objects in the inventory, and in that case you don't need a static body 3D or collision shape. You'll just have to write functions to essentially select the items based on like a cursor object. But in this case, we're going to be using the mouse to select objects and then rotate them and move them around to organize it in the inventory, and then whatever. We're not going to go too crazy. You know, this isn't like something that is, I don't want to make into like a 10 video series, you know, but maybe I will. So once the size is, you get the size, you use the find mesh function, you select the object. You can ignore all of this. This is just some drawing I wanted to do, but here's the next thing that I want to get into, because sometimes you'll have an object that has a rotation from the world where the character picks up an item. It might have a rotated orientation inside of the inventory system, and I accounted for that scenario because I know that that's totally possible, because like for example, this green herb. I called it green herb as paying homage to Resident Evil 4, and I got my green herb object here, and you know it's when you have the green herb in the 3D world space and you're a player, it's like this, and you grab it, but in your inventory it's like this. So basically all that means is that there's going to be a rotation applied on the x-axis, and then once there's that rotation applied on the x-axis, that means we have to account for that. We have to check for that, because if not, we get the size. We're going to see that the y size of the mesh is 2, but since it's been rotated, in reality, that y size is going to end up on the z-axis, as you can see right here. This green herb has been scaled on the y, but it's taking up space on the z-axis because it's been rotated on the x-axis. It's all connected, man. I know. It's all connected. So that means get size with rotation. I wrote a function where earlier we saw that we could have to get the node 3D parent object scale times the mesh's size times the mesh's scale to get the object's size. But if there's a rotation in the x-axis, and honestly, this is never going to be even called. I just wrote that for fun, because I'm not going to have any objects rotate on the z-axis at all, but for the x-axis, we only really care about 90-degree rotations, and we don't care if it's positive 90-degree rotation or a negative 90-degree rotation, because either way, the size is being affected the same way. So we get the absolute value of mesh rotation dot x, and we're rotating 90-degree angles. So, because in the inventory system, you never have objects slanted or disorganized or nothing like that. I was thinking of making an inventory system like that, but we're going to be doing only 90-degree rotations in this system. So I'm just swapping the y and z values. So now in our 3D space, when we get the size of this rotated object, when we get the z size of the object, we're legit getting the size of z on the z size of the object in this. How do I say it? The actual size of the object in the z-axis, like the length of it, you know, from here, my cursor is from here to here. So that's what this is doing right here, getting size with rotation. And this, even if an object has no rotation, you can still call this function, because this and this will be false, and it will just get the size of the object, and calling get size calls this right here. So it is a little bit redundant, you know, if you were to call this for an object with no rotation, because then it's going to end up just calling this anyway. But yeah, anyway, you could just call this for size with or without rotation. I'm just saying, And then for selecting an object, I'm using a global variable is selecting. So first it's false, but once you select an object, is selecting will be set to true. Object is the selected object. It's just a node 3D. So object will be sent to the selected object once it is selected. So let's check out the select object function real quick. The select object, we're selecting, we pass in the object, and we're checking, does this object have rotation? If it has rotation, then we want its size with rotation, else get the size. And as I said before, you could simply replace all of this with object size equals get size with rotation object. You could simply use this one-liner instead of all of this 4 lines, but I just thought I would do that because it's a little bit extra, and why not? It's fun. So then we get the position of the object, and this is the center of the object. And then dx, dz is this is just drawing a line, and this doesn't matter. You don't have to do any of this. This is just extra, but from here, I'm grabbing the bottom left corner of the object and drawing a line from that corner to the top right corner, just for fun, no reason. And then return object. This is returning the selected object. So we don't really care about selecting the object so much as this function that much, but after selecting it, we care about moving the object. And in the movement of the object, it's not completely all done yet, but the base setup that we've got so far right now is that if this object has no rotation, this doesn't matter actually, you don't have to care about that either. And this, you don't have to care about that either actually. Basically, we can just modify the position by plus or minus 0.5 in any direction, 0.5 in the X and Z axis. I do have the bounding formulas to bound it in a 3D space, but that will be for a separate video because this is a lot for one video and I want to split it up. This is incorrect. Please do not use this code. This is incorrect. I have the correct code on my blackboard over here. I can show you all right now. Can y'all see that? So that's just that's a preview of what the bounds will be looking like in the next video. But for right now, that's pretty much everything for this right now. And again, at this point, you should have something looking like this. So let me show you all. If you've been following along, you know, you should be around something like this right here, where you can click on an object and you can move it by a certain amount that's fixed in this grid structure, and you should be able to select a different object and move it, and you should be able to select an object and rotate it. But right now, the bounds aren't set up perfectly. That will be in part 2, so this is what you should basically have right now. And that's about it. That's about it for right now. We'll be using the formulas that I have figured out on the blackboard. I know it's like there's probably like tutorials online that explain like how to bound the axes, but in my case, I'm using a different 3D axis system where I have a minus z direction going upward. So this is minus z, this is plus z, this is minus x, and this is plus x. So your axis, your 3D environment might be different. Okay, so you have to make sure you look at your axes to make sure you're doing the right. Because if you just copy and paste all the code that you see, and if you like pause it, the video at different parts and copy it all, it's not just gonna work if you just copy and paste all of it. Like, you have to also look at how your objects are oriented in the 3D space, and your camera orientation determines this. I just arbitrarily have this orientation of the axis where the z-axis is inverted, alright? Which you may think, why did you do that? That's stupid. It's a horrible idea. It doesn't matter. It's just like a worldview. If you take it in your mind and you like have that as your view, like, it's cool. It's just like everyone's got their own like system that they do it as. So like you might want to personalize it in your own way, and maybe you want a plus z direction here and a minus z direction downward, and plus x in the you know, just like a normal like x. Maybe you want to do like an xy axis and screw the z-axis. Yeah, you could orient your camera like that too. And then you'll have to just swap all the values that I have for x and z, and you can swap it for x and y. So I really should have explained that part first at the beginning of the video, but I'm explaining it at the very end. So I'm really hoping that like you all watch like the whole video and understand like the setup for this, because once we get the bounds set up and the rotations, all we have to do is we can just rotate objects and move them around however we want, and then have like a validation function that validates the whole inventory and checks if your inventory is valid. And if it's not, then we can outline objects that are invalid in a red outline that the user will have to rearrange. And we can also create a function later in the series where we can add items to the person's inventory and keep track of the space that's being taken, and have a whole entire two-dimensional array storing of the object's name, or the object and its position in the space, and we can even calculate the area of each object that it takes in the space, and get the total area of the 3D space, and find how much know exactly how much inventory space we have left in the inventory system. But for right now, I think this is enough homework for you guys, so make sure you study, and the test is going to be very difficult. The final is 100% of your grade, and if you fail, then you're a failure. So please do not fail. Do not fail me now. We have to take over the world in Godot 4 with Resident Evil 4 inventory systems. And I want to see every single 3D video game made in Godot have a Resident Evil 4 inventory system. These are my demands. Alright. Enough rambling. This is all I got for right now. If you have any questions, please leave a comment, and I'll try to explain what's the ideas going on, what the mission here is, what all that. So thank you all for watching. Please like the video, subscribe, whatever. I just hope this helps someone. I hope someone's trying to make an inventory in Godot. It's a really nice game engine that's being slept on right now, and there's no tutorials out here on YouTube. Like, we need way more tutorials on Godot on YouTube. We need way more tutorials about Godot stuff, and more depth, because the stuff is just too simple, too easy. We need like difficult, in-depth, rabbit hole, deep tutorials in Godot 4, you know what I'm saying, bro? So, until next time, guys, I hope you all are working hard and making some cool stuff in a 3D environment, of course.